Today we'll be discussing about NetworkX library. So the NetworkX library is basically a very important library for big data analytics and data science. So it's a Python package which is already created, and it's basically used for creation, manipulation, or the study of different types of complex networks. So it has various applications, and here if we see, it can be used for creating data structure graphs. It can be a multi-graphs or a directive graphs, and also many standard graph algorithms use this package for creating their graphs. And network uh, network structure analysis measure also use these types of use this library, and it can use for generating different types of classics, random or synthetic networks. And here we basically having two main things. One is nodes, and another one is edge. So here nodes can be anything. It can be a text data or the image data or any XML records also. And the edges can hold any types of value. It can be the weight or the time series values, and it depends on the problem we are solving. So basically this is the basic introduction about the NetworkX. So here we'll be using this NetworkX library for creation of graph, and how we can use this NetworkX library for creating different types of networks. And we'll also display the graphs that we have created using this NetworkX library. So for that, we'll first import the library like NetworkX library. So here, this is the first command which can be used for importing the library. So here I have used import NetworkX as nx, and after importing this library I just use that nx.graph function for creating the graph. And after creating the graph I just added some nodes to the graph. For that particular purpose I have just execute a for loop here, and here I start the iteration from 0 to 10. And here I am adding all these values to the graph as nodes. And if we print the values, you can see like it's starting from 0 to 9. So these are all the nodes that are added to the graph. And after adding the edges, we can add some after adding the nodes, we can add some edges to the graph also. So for that purpose I have added these edges, like after edges between all the nodes. So here if we print the z dot edge, you can see it will print 1 2 1 5 1 9 2 5 2 8 2 4 2 9 6 7 and 8 9. So edges are added between all these nodes that is displaying here. Next we'll try to draw this graph that we have created in the above steps. So here I am just printing the nodes and the edges. After that I imported the matplotlib library, which is basically used for drawing or visualization purpose. So here I have imported this library as plt. So next after importing this library I just use this draw function nx.draw, and I pass the graph into that. So it will draw the graph that we have created by using by adding those edges and nodes to the graph. So this is the graph that we have created in the above steps. We can also display the levels that the nodes are having. So for that purpose what we have to do is we have to use this with levels, and I use this with levels equal to 1. So it will basically display the levels levels of the nodes. So here you can see like this particular node is having as value as 7, and this is having 6, like that. So next I tried creating a complete graph with 10 nodes. And complete graph are those types of graph which are like each and every nodes of the graph is connected with other nodes. So this is a complete graph that we have visualized, and here I have added the number of nodes as 10, and this is the drawing function I have used with levels true, that is 1. And if I set as 0 here, then it will not display the levels, because it depends on the value that we are applying. Suppose, yeah, so here if we assign 1, then it will display the values. So this is the complete graph that we have created, and here if we see for node 5, it will connect it with all the remaining nodes, like that all the nodes are connected with each other. The next one I tried creating a complete graph with 100 nodes, and this is very looking like this graph is containing 100 nodes, and each and every node is connected with each other, so it's looking very complex here. So this is the graph with 100 nodes, and in conclusion you can say like graphs and networks are very important in case of data science and big data analytics. So here in this program, we have just given a basic overview about the creation and visualization of some simple graph with nodes using this NetworkX library.